So hi guys, today we'll be discussing problems A, B, C, D, E of Codeforces Contest 976 by Divide by Zero. I think this was organized by IIT Indore. So let's get started with the first problem. The first problem is find minimum operations. You are given two integers n and k. In one operation, you can subtract any power of k from n. That is, formally replace n by n minus k raised to x for any non-negative integer x. Find the minimum number of operations required to make n equal to 0. Okay, so what does the problem say, guys? Let me just show y'all. The problem says that you are given an n and k, and on one operation, you can take any x, any non-negative x, all right, x greater than equal to 0, and make n minus equal to k raised to x. The only condition, like this is the condition, and what do we want to do? We want to find minimum number of moves to make n equal to 0. Okay, guys, this is what the problem says. So, guys, is the problem statement clear? If the problem statement is clear, this is a very simple greedy problem. What do we have to do, guys? We are given an n and k. Do you agree, since we want to make n to 0 in minimum number of moves, all right, on every move, we want to subtract as much as possible, yes or no? Correct, guys? We want to subtract an as large number as possible. Okay. So on every move, what do? We find an x such that k raised to x is smaller than equal to n. And after that, we do n is equal to n minus k raised to x. Yes or no? This will be one move. Then we keep doing this again and again till n becomes 0. Correct? This should be our greedy strategy. This should work, right? Okay. But guys, there is a small issue. Consider that n is equal to, let's say, 10 raised to 5 and k is equal to 10 raised to 9. Do you agree? The only x that is going to satisfy this is 0. Basically, on every move, you take k raised to 0, that which is equal to 1, and you subtract 1 from n. Do you agree? The number of moves required to make uh, n equal to 0 is nothing but 10 raised to 5 here. Yes or no? Or equal to n? Tell me, guys. Exactly. So, the main key observation here is when k is greater than n, it is going to take us n moves. All right. This is the main observation. If this much is clear, this and this, then that is more or less the solution. What do we have to do? While k is smaller than equal to n, there are two parts to this solution. While k is smaller than equal to n, find largest power of x and subtract n by k raised to x. After that, when k becomes greater than n, it is going to require n moves. This is part 1 of the problem. This is part 2 of the problem. Is this much clear for everyone? Yes. So let me just show you all the solution. All right. This is the only thing that was required to compute. So when k is equal to 1, we can print out n. Okay. This is the first case because k raised to any 1 raised to anything will require 1. Apart from this, we have a counter. What do we do? While n is greater than equal to k, we find the largest power of k, which is smaller than equal to n. You can see right here. How am I computing it? I have my result as 1. And while result into k is smaller than equal to n, result multiplied by equal to k. A thing to notice here is that this will run at most 30 times because the smallest k, which is larger than 1, is 2. And since n's largest value is 10 raised to 9, 2 raised to 30 is 10 raised to 9. Okay. So in this case, n minus equal to largest power of k. And after this counter plus plus. In the end, once this for loop is over, do you agree n will be smaller than k? Yes or no, guys? When this while loop is over, correct? Why? So in the end, our answer is counter, basically the number of operations required here, plus n, because since n is smaller than k, okay? Uh, People are asking why won't the largest power of floor of log n to base k? It might be Ved, but the thing is, there might be precision issues. You might have used the log function in C++, and that is why it might have caused precision issues. Okay? All right. So, what is the time complexity of this code? So, guys, this while loop is going to run around log k log n times because consider k is as small as possible. All right. Consider k is a power of 2. Now, since k is a power of 2 and n is, let's say, as large as possible, 10 raised to 9, do you agree for each power of 2, k would get subtract 2 raised to k, 2 raised to something will get subtracted from n? So that is why this will run around log n times. So the time complexity of this code is big O of log n per test case. So number of test cases into log n. Now, since the number of test cases is 10 raised to 4 and log n is 30, it runs in around 3e5 operations. Okay, guys, is this much clear? Let me just go to the code again. Let me know if you have any doubts. A very simple, easy to understand code. Is this much clear, guys? Just put a yes in the chat if it is indeed clear. Great. If it is indeed clear, let's move on to the next problem. The next problem is brightness begins. This brings back a lot of memories to me because this is actually a very famous problem. Like it's a trick. And today I'm going to show you all this trick. So what does this say? Imagine you have n light bulbs 1 to n. Initially, all light bulbs are on. To flip the state of the light bulb means to turn it off using if it is on, otherwise to turn it on if it is off. Okay. So for every 1 to n, you flip the state of all bulbs j such that j is divisible by I. After performing all operations, there will be several bulbs that are still on. Your goal is to make this number exactly k. Find the smallest n, find the smallest suitable n such that there will be exactly k light bulbs on. We can show that the answer always exists. Okay, so guys, uh, this is actually a very, very famous problem. Okay. The problem is as follows. You are given n bulbs. All right. And let's say there are like 10 bulbs. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Initially, each one is on. Let me represent it by 1. Okay. Okay. Now, on each iteration, what are we doing? We are, for example, we start by 1, we flip all the bits, basically, we flip all the states of the bulbs such that their number is divisible by 1. So, do you agree? We would flip everything from 1 to 10? Yes or no, guys? Tell me. Yes?
Yes, sir.
So this would be 0. This would also become 0. This would also become 0, 0, 0, 0, 0, 0, 0, 0. Okay. Now let's do this for 2. You would notice that 2 would become 1, 4 would become 1, 6 would become 1, 8 would become 1, and 10 would become 1. Now let's do it for 3. When we do it for 3, 3 would become 1, 6 would become 0, 9 would become 1. All right. Now let's do it for 4. When you do it for 4, 4 becomes 0, 8 becomes 0. Let's do it for 5. 5 becomes 1 and 10 becomes 0. Now let's do it for 6. 6 becomes 1 and nothing else. Now this becomes 1, this becomes 1, this becomes 0, and this becomes 1. Yes or no, guys? This is what the state of the bulbs would be in the end. Now, this is a very, very beautiful observation that the bulbs that are off are perfect squares. Exactly. And why is this the case? Okay. Guys, for any number, do you agree it will be turned off or on equal to the number of divisors? So, the number, everything is initially on, all right? When a number has odd number of divisors, only then its final state will change. Because let's say something has 2 divisors, it will be turned off and then it will be turned on. If something has 4 divisors, it will be turned off, then on, then off, and then again on. All right. So for the final state to be 0, it should have odd number of divisors. And we know that the only kind of numbers that have odd divisors are perfect squares. Yes or no? So can we say that for a particular, if I have an n set, then the total number of light bulbs on in the end is nothing but n minus number of squares from 1 to n, which is nothing but square root of n, because square root of n10 is nothing but 3. And we can see that 1, 2, and 3 squares are there between 1 to 2. Yes or no, guys? Tell me. Is this much clear? The time complexity of square root is log n. All right. Now, guys, a very simple thing to notice here is that this is n minus square root n for a particular n, correct? Now, do you agree if for n, I have a particular answer x, okay? And for y, n plus 1, I have a particular answer which is x, which is y. Do you agree x will be smaller than equal to y? Yes or no, guys? As I increase my n, the number of light bulbs on will also increase. Yes or no? Like it's going to be at least x, and then it might increase depending upon what n plus 1 is. Okay. So do you see exactly, guys? This is what I wanted to build for y'all. So for n plus 2, let's say it is z. This is smaller than equal to y. Do you see that this right here is monotonic? As we increase n, the number of light bulbs on also increases. Yes or no? Tell me, guys. Now, if this much is clear, can we say that this is monotonic? Basically, it is only increasing. It can never decrease. Yes. Now, if something is monotonic, can't we just binary search upon it, guys? Tell me. Yes. So, what do we have to do? We have to just binary search upon n. All right, this is all that we have to do. Given a particular mid, all right, let's say a n, the number of light bulbs that is on is going to be mid minus square root of mid. All right. Now, if this is equal, we are also given a number n, right? Which is the number of light bulbs they want on. Let me denote it by some other variable. Let me denote it by capital N. If this is smaller than capital N, do you agree we would go towards the right? And if this is greater than capital N, do you agree we would go towards the left? Exactly. So that is all that we have to implement. Let me show you the implementation. All right. So my left is 1, my right is 4 raised to 18, and my answer is initially 4 raised to 18. All right. Um, int mid is left plus right divided by 2. The number of light bulbs on is going to be mid minus square root L of mid. Okay. I'm converting this to an integer because this returns a double. Now, if on is smaller than n, left becomes mid plus 1. Basically, we are going towards the right. Otherwise, answer is mid and right is equal to mid minus 1. Basically, if we find the smallest index where on is greater than equal to n, and it eventually becomes n itself. In the end, I just print answer. It's a very simple binary search. All right. I just took it in the context to be a very large number. You can try with 2e18 as well. I knew for a fact that 4e18 would pass. Okay. So I just didn't think about it and I set it as 4e18. You can set it as 2e18, try. I think 2e18 should also work. Yes, 2e18 should also work ideally. Okay. I didn't put much thought into what should be the exact number, but yes, 4e18, 2e18, all numbers work. What is the difference between square root and square root L? SQRT-L is for large numbers, like which are greater than integer, basically long, and SQRT is only for integers. Okay. All right. I tried this and it didn't work. Yeah, probably because of SQRT.
Sir,
Yes.
sir, like I have not studied binary search, so in this question, I have used n minus root n equals to k, and I have found the value of n in terms of k, which is 1 plus 2k plus root over of 1 plus 4k by 2.
You have solved using mathematics?
Yes, sir.
Yes, that works as well. Like since
But
it is
sir,
an yes.
but sir, I have taken all care of long and all that, but it is showing wrong answer on pretest 8.
Oh, after the contest, after the discussion, let me look into your solution. All right.
Okay, sir.
Oh, okay. Karthik says the value of k was still 10 raised to 18. In that case, how you decide the upper bound for r? Basically, this n, right? This was still 10 raised to 18. So, Karthik, since n is 10 raised to 18, the square root of 10 raised to 18 is 1 9. So, we know that. Um, so, what I'm trying to tell you is, right? How did we define r? So, I took it as 418, but how are you sure that it would fit in 418? So consider n is equal to 10 raised to 18. Basically, the number of light bulbs we want on. So from 1 to 118, do you agree 10 raised to 9 light bulbs are perfect squares? Correct? So in 10 raised to 18 plus 10 raised to 9 plus some constant, okay, plus let's say another 10 raised to 4 or something like that. Do you agree 10 raised to 18 bulbs will be on for sure? Like 10 raised to 4 plus 10 raised to 5 or something like that. Correct? So a good upper bound on R is 2 raised uh 2 into 10 raised to 18. I took it as 4 into 10 raised to 18 because I was not sure on 2 into 10 raised to 18. Okay. But that works as well. Okay. Priyam says how square root n came into the picture. Priyam, very simple. N minus, we want to subtract the number of perfect squares from 1 to n, right? Correct? We want to subtract the number of perfect squares. So from 1 to n, how many perfect squares are there? There are square root square root and perfect squares. Because if you take the largest number whose square is smaller than equal to n, for example, if you see 1, so on and so forth up till 10, 3 square is the largest square that is smaller than equal to n. So will be 2 square, so will be 1 square. So we are just finding this number 3. Okay. All right. So that is more or less it for this particular problem. I hope this is clear for every one of y'all. Now, moving on to problem C. Okay. Now, guys, what is problem C and how can you solve it? You are given 3 non-negative integers B, C, and D. Please find a non-negative integer in range 0 to 2 raised to 61 such that A or B minus A and C is equal to D, where bitwise where this denotes the bitwise OR and this denotes the bitwise AND operation respectively. If such A exists, print its value. If there is no solution, print -1. Okay. So guys, what does the problem say? The problem says that we are given an equation is or A plus B minus A and C is equal to D. Okay. We are given B, C, and D. We want to find A. Okay. This is what we want to do. Now, guys, do you notice that we are not subtracting anything from A or so on and so forth? Like whenever we decide A gets bitwise ORed and bitwise AND. Yes or no? Correct. And the resultant is subtracted. Correct. So usually in such problems, guys, there is a like whenever you want to solve, whenever you're given a bitwise equation and you want to find one variable, you can solve this bit by bit. Okay. And let's confirm if it actually works by solving bit by bit. Okay. Let's take the first example here, which is let's say 10, 2, and 14. All right. And before doing that, Since we are solving it bit by bit, let's make a truth table. Do you guys know what a truth table is? So I hope in college you might have heard of something known as truth table. So let's take the value of B, C, and D, and let's see what the value of A should have been for the equation A or B minus A and C is equal to D. Okay. So the values here are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay. Now, for 0, 0, 0, okay, this is 0, this is 0. Now, on the right hand side, we want 0. So, do you agree A should be 0 as well? Okay. Now, if B is 0, C is 0, and D, we want 1. Do you agree A should be 1? Correct. Okay. Now, if B is 0, C is 1, and D is 0. Do you agree if A is 0, then we are able to achieve this result? Because C and A will give me 0 and 0 minus 0 is 0. Right? Now, this is the first thing that comes to our mind. 0, 1 and 1. If B is 0, C is 1, and if we want D equal to 1. Is this possible, guys? Tell me. Like, can you solve this? No, right? So, this is something which is not possible. All right. Now, similarly, you have B is 1, C is 0, and D is 0. Is this possible? No, right? This is not possible. Okay. And now, um, for 1, 0, 1, here you can set A as 0 and it would work. For 1, 1, 0, you can set A as 1 and it would work. And for 1, 1, 1, you can set A as 0 and it would work. Is this much clear for everyone? Okay. Now, we have come across a truth table and we just want to check. Like, we know that this much works. We just want to know what happens in these cases. All right. Are we really able to come up with a solution or not? So let's take the bottom two examples and solve them. Okay. So let's take 4 to 6 and 10 to 14. So 4 to 6 and 10 to 14. Okay. So let's write 10 in binary, 2 in binary, and so B is equal to 1, 0, 1, 0. C is equal to 0, 0, 1, 0. And D is equal to 1, 1, 1, 0. Yes or no? So we'll just look at the corresponding truth table values. So 1, 0, 1 is 0. All right. 0, 0, 1 is 1. 1, 1, 1 is also 0. And this also remains 0. So A is equal to 4 is a valid answer. Yes or no, guys? Tell me. So is A is equal to 12, but A is equal to 4 will satisfy this equation, correct? Tell me, guys, yes or no? Okay. Now, let's look at 4, 2, and 6. And this is more or less enough to see why our assumptions are correct. B is 1, 0, 0. C is 0, 1, 0. And D is 1, 1, 0. All right. Now, guys, you can see that B is equal to 1, C is equal to 0, and you want D is equal to 1. All right. Now, guys, no matter what you do, this position is always going to be set to 0. Yes or no? Correct? So, we can get a 1 here. Now, main thing is here. All right. If you want to set this, right, like 1, 0, 1, 1 to 1, okay? You might say that if I have A is equal to 1 here, then what would happen? Then, guys, this would also become 1. This would also become 1. And do you agree 1 minus 1 would give me 0? Yes or no? You might thought that we might need some kind of carry or something like that. But do you see carry does not happen at all? So whenever there is 0 here, there is 1 here, and you want a 1, is it really possible? No, right? This case is never possible, because if you are like, if I take it as 1, what happens? Then B also becomes 1, and then 1 minus 1 becomes 0. All right. So no matter what you do, 0, 1 will always give you 0. It can't give you 1. Hence, when you come across these two conditions, when there is 0, 1 and you want 1, and you want 1, 0, you have 1, 0 and you want 0, it's just not possible. All right. And in such conditions, you print minus 1. Is this much clear for everyone? If this much is clear for everyone, this is more or less the solution. You have this truth table and then you just solve bit by bit. So let me just show you the solution. I kind of created the truth table in the uh, class, in the contest as well. For 0, 0 came up with 0, 0, 1 came up with 1, and so on and so forth. And for the conditions which are not valid, you just set a minus 1. Now, you have BCD, you take in BCD, you iterate from bits from 60 to 0. Why 60? Because 2 raised to 60 is 10 raised to 18. Now, you find what is, if the ith bit in B is set, jth bit in B is set, kth bit in D is set or not. Now, according to that, you get the truth table value. If x is minus 1, then you set a to minus 1 and you break. Otherwise, this is either 1 or 0. So depending upon that, I set that bit in A. All right. So that is more or less for this solution. Okay. Hemang says, can we read the part about carry? Definitely, Hemang. All right. So Hemang, tell me this. For 101, we have to set this to 0, correct? And it would work. We would
Yes.
have 1. Now, for 0, 1, okay, we have two choices in A. All right. And we can set A to, in this position, we can either have it as 1 or either we can have it as 0, correct? Yes or no,
Yes, sir.
Himang? Yes. Now, if we have it as 1, B or 1 will give us 1 and C and 1 will give us 1. So 1 minus 1 would give us 0, yes or no?
Yes, sir.
Now, if we set it as 0, this would be 0 and this and with 0 would be 0. So 0 minus 0 would be 0.
Yes, sir.
So do you agree, no matter what I set in A, I will never be able to get 1 over here?
Yes, sir.
Yes, so that is what I explained. All right. Now someone says why 100 would be 0. Very simple. Consider B is 1, C is 0, and D is 0. Now A can be 1 or A can be 0. If A is 1, then this would be 1, this would be 0, and this minus this would give me 1. If A is 0, then this would, yeah. And if A is 0, this would still be 1, this would still be 0, and this would still give me 1. So do you see, for B is equal to 1, C is equal to 0, getting D is equal to 0 is not possible? Okay. Now, Neshwan says, no, that is not possible, Neshwan. If B is 0, C is 8, and D is 8, in this case, B is 0, 0, 0, 0, 0. C is 1, 0, 0, 0, 0. And D is 1, 0, 0, 0. Now you are saying that A is equal to 16. A is equal to 16 is 1, 0, 0, 0, 0. All right. When you OR it with this, you will get 1, 0, 0, 0, 0. When you AND 1, 0, 0, 0, 0 with 1, 0, you will get 0, 0, 0, 0, 0. When you subtract it, you will get 16. Okay, not 8. So in this possible, it is not possible to get an answer. Yes or no, Nishwan? It's a bitwise AND operation. 16 and 8 will give you 0. Now, is this clear for everyone, guys? Tell me.
Excuse me, sir.
Yes, tell me.
क्या हमेशा ट्रूथ टेबल बनाना ऑप्टिमल रहेगा जब भी हमें ऐसे इक्वेशन मिली होंगी?
You can try and see if it works. Like there was a brief period of time where every code chef contest had a bitwise problem on it. All right, and a lot of bitwise problems can be solved by using bit by bit method. Like you can solve each bit separately, and this is exactly what we did in this problem. So you can try and you can see if that works. In this case, I just noticed that you can just solve it bit by bit, and that helps. So you can try.
Okay.
I wouldn't say it works in all problems, but it would work in a wide variety of problems. Okay. So yeah, that is the trick. Like you create a truth table and then you can just solve for that truth table. Is this idea clear for everyone, guys? Very simple to understand idea. If this much is indeed clear for everyone, let's move on to the next problem. Okay, all problems today had some very standard kind of ideas, very beautiful standard ideas. And let's see. So, how many of you all were able to solve the first three problems, guys? Okay, let's move on to problem D. What does problem D say? Problem D says that to play a game, Alice draws a straight line and marks n points on it, indexed from 1 to n. Initially, there are no arcs between the points. They are disjoint. After that, Alice performs m operations of the following type. She picks three integers a, d, and k. Here you can notice that d is smaller than equal to 10. And she selects the points a1, a plus di, a plus 2di, a plus 3di, so on and so forth, and connects each pairs of points with these arcs. After performing m operations, she wants to know the number of connected components that these form. Help her find this number. Okay. So what does the problem say, guys? The problem says that you have initially n points, all right? So on and so forth up till n. This is the first point, this is the second point, this is the third point, and this is the nth point. Alice is going to give you some queries. The queries are of type AI, DI, and KI. All right. This right here is smaller than equal to 10, and this is what is going to help us solve this problem. Keep this in mind. This also teaches us why looking at the constraints is very important. Okay. Now, guys, look at it this way. First of all, let me just change my mic. All right. So let's say AI is 1, DI is, let's say, 2, and K is, let's say, N. All right. Or whatever, N minus 2, whatever, right? So in this, what would happen? Or let's say this is 3. So I would connect 1, then I would connect 1 plus 2. I would connect 1 plus 2 into 2, and I would connect 1 plus 3 into 2. Yes or no, guys? Basically, I would connect 1, 3, 5, and 7. Correct? Yes or no, guys? Tell me if it is 1, 2, and 3, I would connect these points. So I would connect 1 and 3. I would connect 1, 3, and 5. And I would connect 5 and 7. All right. So this is what we have to do. And in the end, we have to print the number of connected components. If we had to print the number of connected components here, so let's say there are only 9 things. So this is one connected component, this is second, third, fourth, fifth, sixth. So there are 6 connected components out here. So do you agree this is what we have to print? Gautam says, can you explain the question again? Gautam, see, there are n points, okay? And this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, Alice has given you some queries. Let's say the first query, you have AI, DI, and KI. Let's say A is 1, D is, let's say, 2, and K is, let's say, 3. So what do? This means that you have the sequence 1, 1 plus 2, so on and so forth, up till 1 plus 3 into 2, okay? 1 plus 2 into 2, and so on and so forth. Yes? Is this much clear? We have this sequence of 4 numbers. Gautam? Okay. Now, if we are given this sequence, we need to connect them. 1 plus 2 is 3, 1 plus 4 is 5, and 1 plus 6 is 7. So we just connect these numbers using arcs. Okay. You just say that all of these are connected. Now, in the end, you just need to print the number of connected components. After processing all Q queries or all M queries, you need to print the number of connected components. Is the question clear for everyone, guys? Tell me. Yes or no? Yes? Okay. Now, the first thing to notice, guys, and the most simple thing about this problem is that D or distance is smaller than equal to 10. Yes or no? Now, for each distance, D is equal to 1, D is equal to 2, so on and so forth, up to D is equal to 3, D is equal to 10. Let's consider each chains, okay? What is the maximum number of elements that can be connected using distance is equal to 1 chain, guys? N? Yes or no? Correct? Even for 2, it is N, 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 and N. Yes or no? Like consider there can be around N arcs that can be present. So, do you guys see that the total number of arcs that are present, like for D is equal to 1, you would have such types of arcs. For D is equal to 2, you would have these types of arcs, all right? So, the total number of arcs is just 10n, smaller than equal to 10n. Yes or no, guys? Tell me. Like, yeah. So, if this much is clear, we have more or less solved this problem. And why is that so? Let me show you all. Let's consider this case, all right. Let's consider a very simple case where we have multiple queries. Okay, this 10, 1, 2, 4, and 2, 2, 4. All right. So let me just write this down. I'm just writing this down, all right. So we have 10 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And for queries, we have 1, 2, 4, and 2, 2, 4. All right. Now, instead of 1, 2, yes, I'm just showing it right now. So instead of 1 to 4, let's have it as 3 to 4. All right. I'm changing it to 3 to 4. Okay. So when you have 1 to 4, do you agree the arcs are 1 to 3? Okay, let me just name these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. I've changed this to 3. Okay, so it's not the original question. Then you have 3 to 5. Okay, this is 2 into 2. This is 3 into 2, and then this is 4 into 2. So do you agree for the first test case, these are the arcs that we are forming? Yes or no, guys? Now, for the second one, do you agree? Let me do this from a second color. And this would probably be 3, all right? Okay. This is the first one. This is the second one. And this is the third one. Yes or no? Aren't these the ones which would be forming? Now, guys, do you see that these arcs are the same more or less? Aren't these the same arcs? Okay. So, consider this, instead of this 4, this is equal to 3. So, this arc is not there, alright? Now, how do we make arcs congruent? Because if we are able to merge these arcs, we can solve it very easily. So, our goal is very simple, guys. We are going to solve for every D. Okay? And we are going to make a graph. Now, since we want to find the number of connected components and we want to basically merge these two, we have two options. Okay? The first option is whenever we find an edge, someone is, I'm just muting Gotham, all right? So sorry for that. Now, guys, whenever we have an edge, we have two choices. For this edge, we can either add an edge in a graph, all right? Okay. What can we do? We can add an edge in a graph. And after adding all edges in the graph, we can do a DFS to find a number of connected components. Yes or no? This is a very standard technique. I hope everyone who has some idea of graphs knows this. Yes? Is this idea okay? Now, the second thing that we can do is we can just use a DSU. What is a DSU? It's a disjoint set union. So a disjoint set union allows us to union two sets in almost constant time. Okay. So if I want to merge this and this, I will just say DSU dot union 1, 3. And if I want to merge these two, then I say DSU dot union 5, 3. And what this does is it adds a edge here and it adds an edge here. Okay. Is this much clear for everyone? These are the two techniques that can be used. Okay. Now, if these are the two techniques that can be used, how to merge the edges is what we want to see. So guys, we are going to use a very simple technique. We are going to solve this piece by piece. Okay. Or basically, for every D, we are going to solve this. All right. Consider D is equal to 2 here and we start at 1. All right. At this particular case, do you see that we can go 3 loops ahead? Yes or no? Yes? Correct? Yes or no, guys? Tell me. Okay. So since I can go 3 loops ahead, I have stored it in this index. I have stored for every 1 to 10. Okay, 1, 2, so on and so forth up till 10. How many arcs I can go ahead maximum? And this can be generated through the queries. This is just 3 over here. So for 2, I have stored 3. Okay. So what am I going to do? I am going to add this edge either using a graph or a DSU. All right. And then we hop over here. Yes or no, guys? So now we had 3 go ahead moves. We used 1 move. So can you tell me how many go ahead moves we have right now? We could go 3 loops ahead. We already went ahead 1 loop. How many loops can we go ahead now, guys? Tell me. 2, right? Great. So we can go 2 loops ahead now, right? We could go 3. We went 1 loop ahead, added this edge. Now we can go 2 loops ahead. All right. Now for 3, do you agree we had the query 3, 2, 3? So from 3, I can go 3 loops ahead as well. Yes or no? So we are going to set this to maximum of 2 comma 3, stating that I have these many go ahead moves left. So the number of moves left, or the number of go ahead moves left, or loop ahead moves, is maximum of 2 comma 3, which becomes 3. All right. So now I go ahead 1 more move. I add this edge. This becomes 2. Then this is 0 over here because it doesn't have anything to go ahead to. All right. Now I go ahead, add this edge as well. Now you can see that I have 1 go ahead left. And then I go ahead here. I have 0 left and I merge it. Since I have 0 left here, I cannot go to the next I plus 2, and hence we break here. Is this idea clear for everyone, guys? For every node, we just store what is the maximum number of go aheads we have from this direction. Is this clear? Like the queries we had were 1, 3, 1, 2, 3, and 3, 2, 3. That is why here for 2 we stored 3, and here for 2 we stored 3. Yes or no, guys? Tell me. Yes? All right. So if this much is clear, we just have to solve for all d. D is equal to 1, d is equal to 2, d is equal to 3, 4, 5, 6, 7, 8, 9, 10. Add these edges into your graph, and after you have created the graph, all right? After the graph is created, what we need to do, we just need to find the number of connected components. All right. So you have 2 choices to do this. You can either actually make a graph and then run a DFH to find the number of connected components. What I did in the contest is just use a DSU to solve this. So let me just show you all the code for this. The code is actually very beautiful and clean. So let me show you all, guys. So I get in query ABC. I am storing that for index A, for distance B, the maximum number of moves we can go ahead is ARR of AB, comma C. Okay, is this much clear for everyone? Yes, it is Navedium. It is this week itself. All right, this week. Great. So after we do this, all right, we solve for every D. Okay, D is equal to 1, 2, 3, up to 10. So the number of iterations we have left is ARR of ij, and the position we are right now is I. So while iterations is greater than 0 and position plus j is smaller than equal to n, basically we can go ahead. We do iterations minus minus, basically we are hopping ahead. We make an edge between position and position plus j. After that, we set ARR of position j to 0 because we have already used this up. And we increment j to our position. After that, we just set iterations is equal to max ARR of position j, comma 0. Please keep in mind that we first set ARR position j to 0. After that, we incremented our position. So this ARR position J is not the same as this ARR position J. Now, since we have created the graph, we want to see the number of connected components. Now you can either run a DFS if you're actually creating a graph, that is absolutely fine. But in a DSU, the number of connected components is just the number of sets of which the parent is itself. All right. So in the end, you have number of connected components, you iterate through each number. And if the parent of that set is the number itself, you increment components. In the end, you just print the number of connected components. Is this much clear for everyone, guys? A very simple to understand code. And here is also my template of DSU, a very simple and easy to understand template as well. All right. Clear for everyone? Tell me, guys. Like if you want to apply graph, you can do that as well. But is the underlying concept clear?
Hello.
Yes.
Gaurish, can you go back to the slide?
Yes. Tell me.
No, the table. Yeah. So this table is for every jump which is possible.
Yes, yes. For D is equal to 1, D is equal to 2, up till D is equal to 10. What is the number of maximum iterations we have got through the queries is what this table stores. All right.
Okay. So basically,
So
we're pre-computing kind of thing.
it's not pre-computation. We are given these queries, yes or no? So we are given from 1 for every distance 2, you can go 3 moves ahead. So that is why at position 1, we store this as 3. But let's say there was one more as 2, 1, 2, 3, and after that 1 to 5. So we would have updated this to 5, stating that we can go 5 ahead. Okay.
Okay.
And then we just use this to iterate ahead.
I was doing it like using DSU, but every time I was doing a new DSU. So that was getting TLE.
Yes, yes. Every time you cannot create a new DSU because that would not give you the right answer, right? Like, because on every iteration, you cannot create a new DSU. Yes or no? Like, for the entirety, you should have one DSU. Like, for every test case, you should have one DSU. And probably why you got TLE is you didn't set this to 0, probably.
Yeah, I didn't do this as well as I don't know. I was confused with I thought maybe my union function was not optimized, but
Okay, okay.
that was okay. Like union was right, but yes,
This is probably the case where you got time limit exceeded. It's very important to set this to 0 because once we have already used this right here, we would never require to use it again. Yes or no?
yes, yeah, it's kind of
Yes.
visited thing, is it? The
It is what?
It is like visited that we do in graph.
Yes, yes. It is kind of like that. Not exactly, but yes, I get what you're saying. Like since we have already used those up, we set it to 0 so that in the future we don't use it again. All right.
Okay. Yeah. Okay.
Okay.
Thank you.
No problem. All right. So if that is done, moving on to problem E. Problem E is called expected power, and it's actually this problem is a very good instructive problem, and we'll be going through one by one. All right. So if you are able to solve A, B, C, D, let's move on to problem E. Even if you weren't able to solve A, B, C, D, I'm going to explain problem E from scratch. So what does the problem say? You are given an array of n integers, A1, A2, so on and so forth. You are also given an array P1, P2, and something. It's an array of probabilities. Okay. Now, initially S is empty. You iterate from 1 to n and you insert AI into S with probability Pi by 10, Pi into 10 raised to 4. Note that each element is inserted independently. We denote f of s as the bitwise XOR of all elements of s. Calculate the expected value of f of s squared. Okay. So guys, what does the problem say? The problem says that we are given an array of elements a1, a2, a3, so on and so forth up till an. Keep in mind that ai is smaller than equal to 1, 0, 2, 3. Okay. Now, the next thing to consider is that we are also given a probabilities array p1, p2, p3, so on and so forth. What does this probability array mean? It means the probability of ai getting picked up is p1 divided by 10 raised to 4. Okay. Now, do you agree we can have 2 raised to n subsets? So for each subset, let's say I picked up let's say I picked up A1, then I picked up A3, and then I picked up A5. What is the probability of this happening, guys? Consider n is equal to 5 here. What is the probability that this happened? So the probability that this happened is P1 raised to 10 raised to 4 into P3 raised to 10, P3 upon 10 raised to 4 into P5 raised to 10 raised to 4. That is not only it, but do you agree we didn't pick up A2 and we didn't pick up A4? Okay. So the probability that A2 we didn't pick up A2 and probability that we didn't pick up A4 should also be multiplied, right? So we would multiply 10 raised to 4 minus P2 into 10 raised to 4 and 10 raised to 4 minus P4 upon 10 raised to 4. This is the probability that we got this subset XOR. Okay. We picked up this element, we picked up this element, and we picked up this element. Is this much clear for everyone? This is the probability that this is chosen. Okay. Now, we have so guys, for each subset, all right, for each subset, okay, we know what is the probability that it is chosen, all right, probability that it is chosen, and we also know the XOR of the subset. Like if I give you A1, A3, and A5, you can tell me the XOR of its element, yes or no? Tell me. Okay. So f of s or f of this set is equal to the XOR of this set. So guys, can you tell me what is f of s the whole squared? Wouldn't it be just XOR squared? Yes or no? Yes. F of s denotes the XOR of the subset. So f of s squared is XOR square, right? We need to find the expected value of f of s the whole square. All right. So we know, guys, that expected value of x is equal to x into probability of x. Yes or no? Tell me. Correct? So here x is nothing but XOR squared. Yes or no? Or let's do this. This is just XOR squared. So if I have all subsets, can I say expected value of x is nothing but summation of XOR of this subset squared, XOR of s squared into probability of s, where s is all subsets of array A. Yes or no? Tell me, guys. This is the probability that this subset occurred, and the XOR of the subset is given as XOR squared. So if we add this over all subsets, we would get our expected value of x. Yes or no? Tell me, because we have this formula. So for one subset, if we have XOR and its probability, we just want to multiply this and we would get the expected value for this subset. So we just add it for all subsets and we would get the expected value of X. Yes or no, guys? Tell me. Correct? Now, the thing to notice, guys, is that the XOR can lie only from 0 to 1023. Yes or no? Because AI is smaller than equal to 1023, are you able to create a XOR which is greater than 1023? No, right? So the XOR lies in the range 0 to 1023. Okay. So think about it this way. We formulated this, but instead of this, all right, for every XOR from 0, 1, 2, 3, so on and so forth, if I am able to get the probability to get this XOR, not for like for if I get all subsets which have XOR is equal to 0, if I add their probability, I would get the probability of getting XOR is equal to 0 over all subsets. Yes or no? Correct? Like if there are 5 subsets with XOR 0, if I just add their probability, I would get probability of getting XOR is equal to 0. Correct? So now, if for all the XORs from 0, 1, 2, 3 up to 1023, if I'm able to get the probability of getting their XOR, okay, can I say that my final answer is just summation of I squared into probability of I is equal to 0 to 1023? Yes or no? Where I denotes XOR. So the probability of getting XOR is equal to 0 is P of I. And then I squared is just the value because f of s the whole squared, right, is XOR squared, which is I squared. So can I say my final answer can be this as well? Like we discussed that the final answer is this, but equivalent to being this, right? Correct?
अगर आपने
Yes or no,
लास्ट
guys?
पीरियड में एक्सप्लेन करा है वो आप रिपीट कर सकते हैं
What?
लाइक आपने ये एक्सप्रेशन कैसे बनाया फ्रॉम द लास्ट स्लाइड
So did you understand that for every XOR, we can calculate the probability of getting that XOR over all subsets? Correct? So we know that E of x is nothing but x into P of x, right? Correct? So x is what? It is just XOR squared, correct? And this is the probability of getting that XOR. So can I say that for each XOR, if I'm able to calculate the probability of getting that XOR, then summation of I squared into P of I for all possible XORs, these are all possible XORs, okay? This is basically my answer, yes or no, guys? Because the XORs lie in range 0 to 1023. Correct? Now, if this much is clear, we need to calculate probability of XOR for each XOR. If we are successfully able to calculate this, we can calculate this entire summation. Yes or no, guys? Like for each XOR, if we can calculate the probability, we can just find the answer. So our goal from the entire problem has now has now deduced to, I need to calculate probability of XOR for all XOR from 0 to 1023. Yes or no? For each XOR, I want to calculate its probability. Okay. Now, guys, for each element, we know the probability of it getting selected, and we know its probability of not getting selected. All right. Do you agree this is just two choices, take or not take? Yes or no? So can we apply dynamic programming to calculate the probability of getting this XOR? dp of I, comma j represents that we are on index I, and the XOR that we have made till now is equal to j. Yes or no? So what is the base case? When I is equal to n, when would we return 1 and when would we return 0? Tell me, guys. If we wanted to make XOR is equal to, let's say, 3, I passed dp of 0, 3. If I am able to make XOR is equal to 3 using the following recursions, when I am at n, what would be j over here? If I'm able, guys, if I'm able to make XOR is equal to 3, right? So what would be here? It would be 0, right? Because let's say I pass 3, okay? Do you agree if I'm able to make XOR of any subset equal to 3, this would be 0, 3 XOR 3, which would be 0, yes or no? Yes? So, when I is equal to n, if j is equal to 0, we can return 1, otherwise we can return 0. Alright. Gautam C is not
Sir.
getting, Gautam C.
Yes.
Alright. Let's say I called dp of 0, 3. This is a recursive function, alright. And we chose some elements which gave me XOR is equal to 3. Let's say I chose A1 is equal to 1 and let's say A3 is equal to 2. I chose these two elements. The XOR of these three elements is 3, correct? Yes. So, since I am defining dp of ij as I am on index I and the XOR of my previous elements is j. Since I have picked only these two elements, do you agree that it would be dp, when I am at index n, it would be dp of n, 3 XOR 1, 2? Yes or no? 1 XOR 2. So wouldn't this be 0? Because 1 XOR 2 is 3 and 3 XOR 3 is 0. Okay. So if j is 0 in the end, we return 1, otherwise we return 0. This is a simple base case. Apart from this, if we are at any dpij, all right, okay, if we are at any dpij, we have two options. Either we take it or we don't take it. Okay. If we take it, what is the probability of taking it, guys? Tell me. Pi divided by 10 raised to 4, correct? Okay. And what are we calling? We are calling dp of I plus 1 and we are going to j XOR ai. Isn't this right? If we take it, we have the probability of it being taken into, we are going to the next element and we are XORing it by ai. Now, if I do not take it, the probability that it is not chosen is 10 raised to 4 minus pi multiplied divided by 10 raised to 4. And what am I calling? dp of I plus 1, comma j. Because it stays as it is. If you don't take it, the XOR remains as it is. Okay. So can I say the probability of getting XOR is equal to j? Okay. from indexes I and further is just the addition of take and not take? Yes or no, guys? For example, let me take a very simple example, okay, guys? Consider you have the number 0 in your array. There is only one element, okay? And you want to make the subset XOR 0. Let's say the probability of um it being chosen is 0.5. All right. So what is the probability that you will get XOR is equal to 0? Do you agree either you will take this element or you will not take this element? Okay. If you take this element, the probability is 0.5, and now you have completed your array. You don't have more choices, and the XOR is 0. Okay. So this is indeed 0.5. Like if the XOR was not 0, it would have been 0. Okay. Now, if you don't take it, if you skip it, do you agree the XOR is still 0? The XOR of an empty subset is 0, right? So the probability of that is 0.5. So given this array, the probability of getting XOR is equal to 0 is just 0.5 plus 0.5, which is 1. And it makes sense because no matter what choice you make, the XOR of any subset is 0. Yes or no, guys? Tell me. So now does this make sense? When I say that dp of ij is the summation of probability of getting that XOR if we take that element plus the probability of getting that XOR if we don't take that element. And what is the probability? It's just probability of getting that element into going to the next state plus probability of not taking that element into going to the next state. Now the next states are dpi plus 1, j XOR ai, and dpi plus 1, and the XOR remains as it is. Is this much clear for everyone? Yes? Gautam says yes. What about others? Okay. Now, if this much is clear for everyone, for every I, all right, we discussed that if I want to calculate a XOR, my final sub-problem would be dp of 0, comma, that XOR. Yes or no? Correct? So, for every XOR from 0 to 1023, if I call this, do you agree I will get the probability of getting that XOR? Yes or no, guys? Tell me. So, if I multiply XOR square by this, and I do it for all elements, and I sum them up, isn't this my answer? Because this is what we had to find. Yes or no, guys? We had to find summation of XOR squared into probability of XOR over all XORs 0 to 1, 0 to 3. So, we just are able to calculate this. Now, let me show you. I tried that during contest as well, and I got a memory limit exceeded. If you look at my dp function, if index is equal to a dot size, return current XOR is equal to 0. If current XOR index is not equal to -1, return dp current XOR index. Otherwise, return dp current XOR index is equal to not take probability. I've calculated not take probability here, all right? So not take probability plus take probability into this modulo mod. Okay. So this solution right here give a MLE. Why did this give an MLE? Because my DP array is n is 2 raised to 5 and m is 1024. So do you agree this DP array would be 2e5 into 1024, which is 2e8 size? Yes or no, guys? Yes. So That is why it given Emily. Let me just browse through the solution for you guys. Then I'll explain what I did to optimize this. So I taken A, I taken B, and then I'm calculating the take and not take probabilities. So for taking I, it is just BI divided by 10 raised to 4. Since it is under modulo, we would need modulo inverse. So it is denominator inverse. And the probability of not taking I is 1e4 minus bi into denominator inverse. All right. Then I just set my dp and then I call this. So sum is equal to sum plus I squared into dp of 0 comma I, where this I is nothing but the mod. Mod runs from 0 to 1023. Yes or no? Is this much clear? Like what I'm doing here? Yes? Now, no? What is not clear? Tell me. Which part is not clear? You can feel free to unmute and let me know which part is indeed not clear. I'll definitely take that up. All right?
सर आप एक इकाई और नॉट इकाई मतलब ये मतलब आपने डीपी भी कहा लगाई है
No,
ये
no,
स्लाइड कहाँ पर है?
this is not the DP. Do you agree this B array gives me the probability or the numerator? Like
हाँ सर
this is the numerator, correct? This P is the numerator. So the
यस सर
probability that the first element is taken is 5000 divided by 10 raised to 4,
राइट
correct? So I am just storing that as the probability here. Since it is under mod. So guys, if you have doubt here, it means that might probably have doubts in modular arithmetic. So guys, we can't store it as a double because we have to, let me show you all, right? I think this is the part which was not clear with majority of people, that it is given here that if we want to uh, show P divided by Q under modulo mod, all right, we can't just store it as a double and then take the mod. What we have to do is we have to do P into Q inverse modulo mod, all right. So what is this? This is just P into Q inverse, and Q inverse happens to be Q raised to mod minus 2. This is Fermat's little theorem. This is just basic number theory, all right. So the probability that I took the ith element is numerator divided by denominator, and the probability that I didn't take it is 10 raised to 4 minus numerator divided by denominator. Now is this clear? I am just calculating the probabilities that we took or not took an element. Clear for everyone?
दिस स्टेप इज ट्रू
Great. Now, if this much is clear, do you agree that when I call f of 0 comma I get the probability of getting that XOR? Yes. So f of 0 comma I gives us the probability of getting XOR I. So what do I have to calculate? Summation of I squared into probability of I. So do you agree this right here will give us our final answer, this for loop, where this is our DP, which calculates the probability. So this was giving MLE. And why is this giving MLE? Because the size of this array is 10 raised to 3 plus 2 raised to 5, which is 2e8. Do you see, guys, that the DP of XOR comma current index is dependent on only the next index, yes or no? Tell me. It's only dependent on the next index, correct? So do you see that we can use space optimization right here? Instead of storing for every index the DP table, we can only store 2 DP tables. Let me show it to you guys, okay? Instead of calculating it for every index, okay? Do you notice that we came up with this particular value, like dp of ij depends upon dp of I plus 1. Okay. So if I calculate dp of I plus 1 comma everything, okay, do you agree to calculate dp of I comma whatever zor you want to calculate? I just need this table, which is dp of I, and then using this table I can calculate this table. So using space optimization, first we calculate this table, then using this table we calculate this table, and now when we want to calculate dp of I minus 1, we just erase this table and now use this table to calculate dp of I minus 1. These are the only things we do. So using only two tables of size 1023 or 1024, we are able to calculate this. So using this, we are able to avoid MLE. So let me just show you. So you can see that we have this is just space optimization. So we go from index is equal to n minus 1 to 0 and current zor to 0 to m. And we have dp and ndp. Since our base case was when current zor is 0, then we return 1. So that is why dp is 1. Now, ndp of current zor is nothing but the same thing that we wrote down in our recursive dp, which is not take into dp of I plus 1 current zor, which is just dp current zor, plus 1 ll into take plus dp current zor a of index. All right. And after calculating this, you just swap dp and ndp. Once you have done all of this, the answer remains as it is. Sum is equal to sum plus I squared into dp of I modulo mod, and then you return sum. Is this much clear for everyone? Great. If this much is clear for everyone, we successfully conquered problems A, B, C, D, and E of today's Codeforces contest. They were very good problems in the sense that each problem taught something new, especially problem E, which taught us how to use probabilities and how to calculate probability using dynamic programming. I hope you liked today's post-contest discussion. If you have any feedback, feel free to put it down in the comment section below, or do let me know. See you guys next time. Till then, bye-bye.
Sir,
Yes.